So, today we have planned our demonstration based on the lessons that we have learned in the last two modules on multithreading in Java. So, as you know, we have discussed about multithreading concepts, and here basically we have discussed about how the threads can be created, and then the process communication among the different threads, the states of different threads, and finally, the synchronization aspects. So, in today's demo we will learn everything from the practical point of view. We will see exactly how thread can be created and then those thread can be executed. And then we have already discussed that there are two ways of creating thread. So, using thread class and runnable interface. So, we learn about these the two things, the two ways of creating the threads and running them, and there are different methods to control the threads. So, there will be sufficient demonstrations on them, so that we can learn about what are different methods to control the threads. And then for the inter process communication, again there are few methods. We will see exactly how these inter process communicating methods can be invoked for the threads, and then again the thread can be controlled. Now, finally, we will discuss about one real life example, is very small example. So, banking transaction. So, how the transactions in a bank right for the operation of an account holder can be managed, and that is the using threads itself. So, this is basically by the process of synchronization. So, we will discuss about these things. So, let us have the demo on these aspects. So, first we have let us have the demo on how we can create a thread using thread class. So, in this program, as we see here okay, this program, if you see here, we have created three threads, namely here we have created three threads, as you see threads A, and this is basically extends thread A. This means this basically threads using the class threads. And so, creating a thread means you have to override the run method, and as we see we have overriding the run method here, and this run method is basically, as we see from this code, this run method will run for 0 to 5 loops, and in each loop it will print the negative number. So, starting from minus 1 to 5 line. And next thread, so it is the thread B, again it is extends the thread class, and here also we override the run method. This also loops for 0 to 5 6 times, and in this loop, as we see, this method will print the first 6 even numbers. And similarly, another thread C, it is also a extension of class thread, and then here the run method, which is basically a simple loop here, and then loop will run from k equals to 1 to k, that means 5 times, and here it will print first 5 odd numbers. Now, so these are the three threads. So, our plan is to run these three threads simultaneously. Now, here is the main method, and in this main method we see how we can create the three thread objects A, B and C. These are the three thread objects for the three classes like thread A, thread B and thread C. Now, this is the syntax, as you see how we can create the three thread object for the three thread classes that we have defined here. Now, in order to run the thread, so we have to call the method start for each thread object. For example, A dot start, this means that thread A will run, B dot start, that this will run, C dot start, this will run. So, here in this main method, as we see, so these are the three threads will run, but in addition to the main method itself is a thread. So, altogether here actually 4 thread will run. So, this is the thread A will run, this means this thread will print the negative numbers. Thread B, when it will run, it will print odd even numbers. Thread C will run when it will print the odd numbers, and here this main thread, other than this executing or invoking these threads, it will also print this statement, and we are not sure the which thread will be executed in which order, because here the scheduler will take all the threads and depending on its own, because here no priority has been assigned, actually all threads are in random pattern, it will be executed. Now, so this is the program. Now, we can have some idea about how this program, if it run, then how it will give us the output. So, name of the program as we have given here, demonstration underscore 11.1. Okay, so, this program is now compiled and then we are running this program, and yeah, as we see this program, it gives the output here. Multi-threading is over, this is basically from the main thread, and here you see thread C, thread B, A, B, B, they are basically in random order. Somehow thread C, which was already invoked in the main method last, but it got executed first, and then B, A, B in interleaving manner, and we see all thread when they are executed, they are printing their number in that order. Of course, in the way the loop will executed. So, this basically example gives that how the different threads will be executed, and that is the execution of the 3 threads. Now, let us have the another demo. So, in this example we have created 3 threads using class thread, that is the extends thread. Now, there is another way of creating threads and running them using the runnable interface. So, this is a program which basically gives us an idea about how the same problem which we have implemented using thread class can be also implemented using runnable interface. 11.2. Okay. Now, so this is the example what we can see here, how the thread can be executed using runnable interface. Now, let us see, we define thread X, the another thread which implements runnable interface. So, implements runnable, that means we want to create the thread using runnable interface. In runnable interface, there is an abstract method which is basically run. So, here basically implementing means we have to override the run method. So, this is the code that basically implements the run method, and this implementation is same as the thread A extends thread class in the last example. Similarly, thread Y is the same version of thread B, and this is the implementation of run method for this thread X, and similarly this is the implementation of run method for thread G, it basically implementing runnable interface. So, as we see, there are 3 threads we have created using runnable interface. Now, let us see how we can create the. So, these are the basically class declaration for the 3 threads, and now this is the main method. This method is basically creates the 3 threads as we defined, thread X, thread Y and thread Z. Now, here you see, first we create a X, it is basically the object of the class thread X, and then we create a thread of that objects. So, this is basically T1 is the thread object for the class thread X. So, to use it using runnable interface method, we have to have this syntax like thread T1, that means T1 is a thread, and we pass the thread class, that is the X object, which is basically implementation runnable interface actually, and then so this basically create the thread T1 for the thread X. Likewise, this basically T2 is the thread 2 for the class object Y and thread Y actually, and this is another way shortcut method also we can use. So, T3 is the thread object new thread, and in this constructor, so there are different constructor as we see to create the thread. This is the one constructor where you have to pass the object of the thread, but here we can pass the constructor directly. So, this is another way that the thread object can be created. So, this is the one way of creating, alternative way actually. Anyway, either this way or this way you can do, whatever it is there. Now, so we have created 3 threads T1, T2 and T3, and now we are in a position to run them. So, here again we run T1 start, T2 start, T3 start, means 3 threads are now started okay, invoked for their running, and then this is basically the statement which is basically in the main statement. Basically the same program that we have done using thread class, but here only the difference is that we have done the same thing using runnable interface, and definitely it is basically same program, but implementation is different. Definitely they will give the same output. Now let us see the output of this program. Okay. So, this thread, as you see, x, z, y, z, all these things run in an interleaving manner, because whenever the thread is executed they are basically executing parallelly, but here in our display we are producing the output synchronously. So, better can be that, okay, if we have the 3 display unit, for each display the different thread can produce their output, then we can see that how the 3 threads are running independently rather. But here is basically we are producing the output from the 3 threads on the same input, same output screen. So, that is why we are getting the output in the interleaved manner. So, this is the way of creating threads. We have learned about we can create threads in 2 ways using the class thread and the runnable interface. Now, our next illustration is basically to every thread, whenever it is in execution, from the program point of view we can have information about the threads by means of their identity. So, the ID of a thread can be accessed by a method called the get ID, which is defined in the class thread in the java.lang methods class. Now, here let us see one example, as we see here. Now, so this basically this is the name of the class that we are going to declare is the thread ID. Thread ID is basically extend thread. Always whenever you have to create thread class, you have to have an extension or either thread class or implements runnable interface. That is the basic concept, of course. Now, here the run method, basically thread has its own abstract run method, but whenever we have to extend it, we have to basically implement override this run method. Now, this run method is very simple. Here basically it includes one print statement which print the thread, the current thread. That means whichever the thread is in execution, it will basically for that thread, and then dot get ID means for that thread the ID, and it basically it will give the things that which is the current thread is in execution, and corresponding to that thread what is the ID will be displayed and print. And so, this is basically under try and catch exception to handle the exceptions if any things occurs whenever this program is in execution. Now, here is the main method. Here you can see in this main method there will be in fact I equals to 0 to 8, that means 9 threads will be executed. We are basically running for the same class thread ID, but 9 occasions. So, the 9th thread will be executed, and here although we are calling in this way, but whenever these threads are in execution, they will be executed simultaneously in parallel. So, concurrently. So, this basically it creates a thread in each loop, and then that thread is basically executes. So, this actually this way the 9 loops will be created, 9 threads will be created, and then each thread will be executed. So, this is the basically idea of the program, and in this program as we see the output, this program will display the output whenever each thread is in execution and corresponding to their ID. Yeah. So, as we see here thread that is I1 is running, thread I5 is running, I4 is running. Now, we can see 1 to 9. So, 9 threads are basically in execution. So, this way we can see the threads are executing in parallel, but it is not sure if we run this program again, not necessarily in the same output will be. Let us run the same program again. As you see, possibly it will give you the different ordering of the execution. As you see here, in this case obviously in the sum, but here in the last 3 we can see the different ordering. So, ordering is in fact probabilistic, or it is not predictable, rather unpredictable ordering actually. Anyway, so this is the idea about, as we see, is a simple example where the ID of the thread can be accessed whenever a thread is in execution. Now, our next program basically the same, but using runnable interface. As we have seen in the last program, we have created the thread class, we have extended the thread class, again the same program as we see here using the runnable interface, same code, but only the implement, this is the different, and here again as usual. So, this is also different, because in order to execute or in order to create a thread which has been implemented by runnable interface. So, this is basically the structure of syntax that we have to follow, and then we have to just as in the thread class we have to just invoke the start method for each thread to run it. So, this will create one object each time the loop will roll, and then it basically start again the same output, similar output as in the previous illustration, we will be able to see it. So, here is basically we are running the program here. Okay. So, we can see the similar kind of output as we can see. Okay. You can see the bigger screen, so that we can see it clearly. Yes. Okay. So, this is the basically output as we see. So, here basically in the different order as we see, this is basically same program, same logic, but that logic is implemented using runnable interface. Okay, now, our next illustration to express the different states of a thread, and as you know the different control by which the state of a thread can be managed. For example, there is yield method, stop method, suspend method, resume method, sleep method, whatever it is there. Now, in this example, we will just see exactly how the sleep method will work for us, and then stop method also we will see yield, stop, and then sleep. These are the three methods. We will see how these methods can be invoked for a current thread under execution. Now, here is the code. As we see, we create class A extends thread, and here we again override the run method. It is a simple print statement that from which thread this thread is in execution. So, it gives that start from thread A, and this is basically the loop. Here we see for I equals to 1, I less than 5. So, 1 to 5 this loop will roll, and if I equals to 1, the yield method it will be there. So, then system dot out dot print from thread A I plus 1, it basically print the value of I. So, yield method is basically tell that this thread is in execution. Now, here again class B extends thread, as you see the similar structure of the program code here in this run method as well as, but here j equals to 1 to j less than 5, this run method also will roll for 5 times, and here whenever j equals to 2, it basically stop. That means, this thread will be after the running of 1 and 2 from 2, okay, for the third loop onwards it will basically stop, and then okay, stop for some times until it will stop, means it is totally stop. This means this thread will no more execute. That means, this loop will although for roll for 5 times, but it will ultimately work for you only for j equals to 1 only. Now, here again class C, this is another thread we have created here, similar run method k equals to 1 to 5, and here we see when k equals to 3 we call the sleep, and this sleep is 1000 millisecond, 1000 millisecond 1 second like. So, this thread will sleep for 1 second, that means it will roll k equals to 1, k equals to 2, whenever k equals to 3 for sleep 1 second, and then again it will roll for 4 and 5. So, these are the 3 thread classes we have created having their own mechanism, and now we in the main method we can create the 3 objects of these 3 thread classes T1, T2, T3, and then we just start their execution here, and then finally, once the thread is finished, it basically print that end of the thread execution. But as it is here in this main method, actually in parallel 4 threads will run concurrently. So, this is the idea about 3 threads here, and here is the again output. You can see how this program run. Okay, fine. So, this is a warning, we can ignore the warning. Yeah. So, as we see the output seen here, okay. So, end of execution, somehow it is the last statement, but it is the one main thread, somehow it is executed first, and then thread C, thread B in a random fashion, as we see the different threads executed. And also we can see the second thread, thread B, actually as it is run, it is basically stop for thread 1, right, for the loop, and for the 2, 4, 6 it is basically running. So, this is the way it is basically it works for us. Now, let us go to the program here, the program which we are discussing. So, what essentially the multi-threading basically it is there. So, as we see, each thread has its own code. Now, again for example, say suppose we want to run two methods, one method will be for sorting some array of elements and another method for searching some elements in an array. So, what we can do is that we can create a thread for the sorting method implementation, we can create another thread for implementation of searching method. So, whatever the logic there is to sort some array of elements, we can write the code under the run. Similarly, whatever the code that is required to search an item in an array, we can put into the run method. So, this is the way that we can run our own what is called the algorithm, the method, and then those algorithm can be executed in parallel. So, parallel execution means that they will share the system maybe in a time sharing basis or in a multi programming basis, that is the part of the operating system. So, operating system, that means here Java runtime manager will manage the execution of all the threads in parallel. So, this way actually if we run say sorting and searching one by one, so this may take say 5 plus 5 10 seconds, but if you run in parallel it may take 5 seconds. Both the program will run, but it will the maximally utilize the CPU resources, other resources those are required in your program execution can be maximally utilized. So, this is the purpose of the thesis, purpose of the threads execution. Now, let us have the another example. As we have learned the method yield, stop and then sleep. Likewise, there is some other method also like suspend and resume method. So, these examples basically explain us how the suspend and resume method work for us. So, suspend method means if you if you can wait make a thread wait by calling some method, right, then suspend method is basically okay, any one method is running and you can call the suspend method, that means this thread will be not permanently stopped, it will be temporarily withheld, and the same method can be again revoked if we call the resume method. So, here is a program which basically explain that we suspend one method or thread and then the same thread can be resumed from the other thread exactly. So, here is the code. Now, here you can say thread 1, we create one thread and this is a run method, is basically simple, it states that a print statement that this thread starts running, and then here the sleep method we call, we have to sleep for 10 seconds and then the system dot out println the first thread finish running, and then this is the thread 2 and here again the similar kind of code, here is basically thread we call a method suspend, and then the two threads are here. So, the thread this whenever the two threads are in execution, one thread will sleep for 10 milliseconds, another thread will go for suspending. Now, here in the main method as we see, we run the two threads first and second, namely here, and then start it and then execution. So, now let us have the code for that quickly. Yeah, as we just output is little bit bigger, so that you can see it output. Okay, fine. Now, here again we see the output, as we see these are the thread was in execution. So, sleep, and that is why after 10 seconds this sleep, this thread actually revoked and then it produces the output like this one. So, you can see that how the suspend and then the sleep, the similarly resume method also we can call the resume method in the main method, after some time the resume method can be called so that it can resume it. Now, so this is the different method to control the thread. So, is basically mechanism the way that different thread can be controlled. Now, here we have discussed about a priority can be assigned among the threads. Suppose while in the execution we can set some priority to the threads, as we have discussed about, there are 3 priority: mean priority, max priority and normal priority. Now, the thread we can assign priority values to all these threads here. Now, this program will explain how we can create 3 threads, and among these 3 threads we can assign the priority. So, class A is a one thread. This thread has a simple loop I equals to 1 to 5, and then this is a simple loop execution. It will print the 5 numbers, actually 1 to 5. Similarly, class B also similar, it will print same number 1 to 5, and class C also same. So, both the threads are basically similar form of executions. Now, here as you see in the main method, let us look at the main method. We created three threads T1, T2, T2. We create 3 threads T1, T2 and T3 here for the class thread A, thread B and thread C, and then here the method set priority, which is defined in the class thread, and then we pass the argument as thread dot max priority. This value is already defined in the thread class. So, here basically T3 has been assigned the maximum priority, and as you see T1 has been assigned the lowest priority, and here T2 the set priority, get priority, whatever the priority of the thread at present, it is basically +1. So, it is a random priority. Then 3 threads are executed, invoked, and then finally the main thread it is there. Now, we will see. So, the order actually whatever it is there, as you see the max priority having the thread T3, it will be executed first. So, scheduler will know from this information that which thread needs to be executed first. As we see here, because T3 the thread C namely having the highest priority, and as you see here basically it basically invoked first, then B and then A and B, they are basically random priority based on, and they have been executed. So, this way we can assign the priority to each thread, so that the execution of thread can be further controlled. Now, so here is another problem. This is very interesting problem. Multi-threading works good, usually fast, but if you are not careful, then you may not get the right result. Now, in this regard, there is a problem. So far the concurrent program execution is concerned, it is called the race problem, the data race problem. Now, if we see the code here, now this code is very simple. As you see, it declare one integer as a static x, and the run method is basically overridden the class method here, and here we see x equals to x plus 1, x equals to x plus minus x minus 1. Now, after the end of the loop, if we come here, so what will be the desired output? Output will be 0 if x is initialized as 0, is not it? But here we see whenever we run this program, it may not produce the result 0 always. This is because it is an intermittent way. This statement will be executed by the scheduler in a different way, and that is why it is not atomic. So, rather non-atomic the execution. So, whenever we run this main method, I mean run this loop for say here 1000 times, and each time not necessarily 0 output will be produced, it can produce non-zero output as well as. Now, let us see the execution of this program. But in the different instances, if we run the different program, it will produce the different result. So, basically 1000 output has been printed on the screen, as you see all 0 0, but here 1 is there, and if we go little bit also top also, as we going here, maybe that okay, sometimes it is there. So, this is not the right output, actually we can say the erroneous output, and it may produce 0 time most of the time, but sometimes it can produce the value 1 because of the data race. Now, data race, because this is the program, those are the thread under execution, they are not synchronization. Under synchronization means whenever one thread is in execution, then other threads should not be executed simultaneously having accessing the same variable. Here we have made the static variable, basically the different thread takes the same value on their own execution, that is why the data race is coming. Now, this is the one example which can better explain in our real life situation the data race condition. Now, this program let us have the discussion on this program, then I will explain its execution and then the inherent what is called the point in it. As you see here, we first create an account. This account has 3 fields, balance and account number, 2 fields rather, and one method display balance. So, it is very simple class declaration as we declare here. In addition to this method has one method is called deposit. So, it basically deposits certain amount here into this account. So, that means whenever this method will call, the balance, whatever the current balance will be increased by the value of amount. So, this is the code, it is there, and finally, it will print the display balance which is declared here. Similarly, there is another method that we have declared here, withdraw, and it basically once amount will be requested for withdraw will be deducted from the balance, and after the withdraw is over, it will basically display the balance information. So, this basically a simple one class method. This is just regarding an account holder information. That means, the account holder, the name or name is not there, account number is here, balance is there, and the balance information, balance status, and if the account holder wants to do a deposit, so he will just call this method, or if you want to withdraw something, you will call this method and this method will be executed there. Now, here is the question, point is that if suppose 2 customers having the same account number, joint account number maybe, they want to issue the 2 method deposit, withdraw, or deposit again, or withdraw, or whatever it is there from the 2 different terminals, then they will be executed from the server point of view. So, it is basically executed as a thread. Now, again just like a data race, if it is not properly synchronized, then this may leads to the erroneous result. Say balance is 1000, deposit 500 and withdraw is 300, the result may be sometimes 1300 or result may be sometimes 700. So, is not total correct. Now, here is basically the remedy. Remedy is that if we want to make the 2 methods synchronized by force, then we can create the synchronized keyword. So, once the synchronized keyword is placed, then this deposit and the withdraw will be controlled in a synchronized. That means, only one operation either deposit or withdraw will be executed, not the 2 operations can be executed in concurrent, in parallelly. Now, having these are the class information. Now, here is basically 2 methods we declare as a transaction deposit, basically in order to access the account having the transaction here. So, integer amount, this is the account, that means which account the user wants to access, and this is basically the code for this one, and finally, this transaction deposit will be executed in parallel. So, thread. So, this basically creating a thread for accessing this deposit method. Now, similarly, there is a transaction withdraw in the same structure as we see here. It basically create a thread in this case, and then this thread will be again can run concurrently with the transaction deposit. So, these are the 2 threads in this program. So, now after the 2 threads are there, this is the main thread. This main thread is basically execute the 2 threads that we have created here. As we see, we have created an account information, that means an account is created. This is the account, say name of the account will be AB, balance is 1000, account number is this one, and here actually you see T1 and T2, the 2 threads are created. In this case from the same program, but whenever the distributed environment is there, these 2 threads can be executed from the different client and it can pass to the server. You can understand that this is basically the request to the server from the 2 client, that means execution of 2 threads T1 and T2. Now, if these two threads are to be executed by the server in concurrent, then definitely data race may occur, but here these threads are created or called for depositing 500 and withdrawing 900, and then what will happen? It will give always the correct result. So, in this case 1000 is the balance, and after we depositing 500, so total 1500, then after withdrawing 900 it basically 600. So, this is the output as you see here. So, 500 is deposited, this one 900 is withdrawn, 600. So, this is the correct result. Now, I can run the same program, but removing the synchronizations. It will run again just quickly, yeah, we just, but in some situation may not always, it can give erroneous result. Now, here you can see, yeah, so this is the right output as we see here, just bigger. Now, see, in the first execution the output was correct, but whereas this execution the output was not correct in that sense, because they are not executed in synchronization. If the amount is different, you can get the another result also like this one. Anyway, so this basically shows that how the synchronizations can help us to synchronize the program. Okay, so we have learned all these topics here, and go to the, yes, yeah, fine. But the thing is that this is just okay, only tip of the iceberg, we should say. There are many more things that you can consider while you have to practice it. More programs are there from the website link which we have mentioned very beginning. You can follow many more programs, you can access from there, and you can run those things there. If you have any doubt, any query, you are feel free to ask us. Thank you very much.